Welcome to the SBGrid YouTube channel. Software tutorials by developers, lectures by structural biologists, unique content brought to you by SBGrid.
Hello, everybody. Welcome to today's webinar in the series, the SBGrid University of Wollongong, University of Otago webinars on CryoEM and micro-ED. This is the fifth in the series of talks, and we've seen expert practitioners, we've seen discussions on sample preparation, discussions on data processing. Today, we're going to have a discussion on infrastructure for CryoEM that's available in Australia. And we have a number of guests scattered around from locations scattered around Australia. Today's session will be moderated by Associate Professor Isabelle Lucet, who is the head of chemical biology at ACRF and Victoria, and we look very much forward to hearing from her.
Thanks a lot, Kurt. So it is a great pleasure today to welcome our four panelists, fantastic panelists, to showcase Australian CryoEM infrastructure. But before we begin, I would like to celebrate and acknowledge the traditional owners and custodians of the land on which I'm connecting today, which are the Wurundjeri people of the Kulin Nation. And I also like to extend this respect to the elders past and present, and extend that respect to all Aboriginal and Torres Strait Islanders peoples. So our great panelists are Eric Hanssen from Bio21 Institute. Then we also have James Bouwer from University of Wollongong, and Harry Venugopal from Monash University, and Melanie from the ANU. So the way it's going to work today, each of the panelists will give a short presentation of their facility and what their facility, and we'll go then after those presentations go to a discussion panel. So if you could wait for your question, you can put your question on a Q&A site that is available within Zoom, and that would be great. So first speaker is Eric. So Eric is currently a professional fellow at Bio21 Institute and at the newly established Jan Holmes Imaging Centre. He joined the University of Melbourne in early 2010 after postdoctoral studies at the University of Adelaide and La Trobe Uni, where he respectively studied the extracellular matrix architecture and ultrastructure of the malaria parasite Plasmodium falciparum. So his research interests are really mainly in 3D imaging using electrons and SEM tomography and CryoEM. Eric, all yours.
Well, thank you, and thank you for the organizer for inviting me today. I will start sharing my screen. Let me know if it works or not. Do you see anything? Because I don't see a change. Yes, I did see a change. I guess today what I'll do is I'll probably like the others, I'll show you what kind of gear we have, and then what we can offer in terms of helping the community out there. Then if you have any questions, my email is up there. I put it also in the last slide. As Isabelle said, I'm heading the Jan Holmes Imaging Centre, which is kind of a new centre, but it's a new building. We opened a year ago, but the facility exists or has been existing for over 16 years now. And I took the head of that in 2010, but we designed a new building in 2016 and finished the building late last year. Okay, we are located very close to the Melbourne CBD, 20 minutes from the airport, in the campus, the Parkville campus, which has about 10,000 biomedical researchers, and it's a very vibrant biomedical research community. We have a large building with 10 microscopes, and we have capacity for a couple extra columns if we need to. Amongst you, we can put another Krause. In terms of gear, we have a few SEM, and I guess for this talk, the main one is the Aquilos CryoFit. That's for I guess, sample prep in tomography, and it turns out you can pretty much do anything else as well, like a standard field does. We've been running some trials lately, but we have it mainly for lamellar prep for cryo. We have a couple more SEMs. And then we have a lot of cryo-TEMs. We have 5 cryo-TEMs, a Talos L120C for sample screening, a Techni F30 for, I guess, screening the sample. I guess it's using Formula One for going shopping, but it doesn't really matter. You can still use it for that, or tomography as a GIF on it. We have a F20 for sample screening as well. And in terms of automated microscope, we have a Titan Krause, which is a G4. It's arrived a year ago or so. It's running very well. It has a SETA, a Falcon 4, and a K3 with a GIF. Talos Arctica, that's a bit older now. It's I think 2016, with a SETA D, a Falcon 3, and a GIF K2, and then a Glacios that's housed in the facility that belongs to Monash University, but we have access to it 3 days a week. And it has a Falcon 4. Microscopes are good, but you need people to run these microscopes, and we have, I guess, few staff members. I guess I am mainly interested in tomography and cryo-EM, and I have 2 staff members, Hamish and Sepide, who do only cryo-EM. Sergey is responsible for the cryofib and other material, and also some material science. Zlatan is responsible for the biosample prep, mainly for plastic embedded, but he will be upgraded to cryo very soon. And then Rogers does cryo-SEM on the quanta. And then we have some link staff, Andrew List, who's at WeHi, and deal mainly with the WeHi user, but also help with the microscopes. Matthew Belsoff from Monash to take care of the Glacios, and we have a Thermo Fisher field service engineer on site 24/7. Well, not quite 24/7, but very close to that. He's basically here every day to take care of the microscopes. In terms of ancillary equipment, we have sample prep, then we have Vitrobot Mark 3, Mark 4, Leica GP2, and then a manual punch freezer that we can put in our cold room. We have a cold room dedicated for sample prep. It's not used much because people prefer the automated system, but if you want to do manual, we can do manual. And then we also, for the tomography aficionados, we have a CryoClaim Leica system, basically to work on the workflow from cryofeed to tomography. After that, to transfer the data or data analysis, we run CryoSpark Live on every academic projects that run on the Krause or the Arctica, if it's requested. If the users do not want it, we don't run it, but it's possible, at least for academic projects. And I think at the moment, CryoSpark will be running for, at least for my project for the last 5 days non-stop, and it's working very, very well. And then we transfer the data live to our data transfer system, which is MediaFlux. And then you can access the data from the MediaFlux server or the Melbourne Uni server after the data is collecting, or I think we're trying to work out at the moment a way of transferring it live to other servers. But it runs very well. We have 10 gigabytes link to the rest of the world. Then it's decently fast. We can transfer directly to your server if needed. That's what we do with the Glacios that belongs to Monash. We send everything directly to their server. And if we have an address, and if all the firewalls are open, we can send it anywhere. We run it as open access, and basically we accept everybody and anybody. If you want to do a job, we don't screen the research project. If you have a sample that's ready, we will run it for you. Then there's a couple of things for that if you can't make it. But our favorite way of working is training people how to use the microscope, because it's more fun for everyone. You learn new things. We learn new things about the biology, and then we meet in the middle. Collaboration is also our second favorite way of working with training, and we can do that on close supervising students. We can run some small or even large projects. There's pretty much the sky is the limit. Mainly the amount of sleep that me and my staff are having are the limits. Or we can do fee-for service, but that we are limiting this to very small projects for negative staining. And we can also, and for CryoEM, we limit to the acquisition on the Krause and the Glacios if the CryoEM samples are already pre-screened and if the grids are ready to go. If we have to start preparing grids and and screening the grids and all this becomes a collaboration, because it's a very heavy involvement, and there's sometimes some I guess some intellectual, not property, but some input, intellectual input in the project. In terms of capacity, the Krause and the Arctica are currently running at 20% capacity. Then we have plenty of capacity on the microscope. What limits us is mainly the availability of my staff and me, but we have some capacity, no problem, depending on the project. At the moment, I've been working for the last week on a project that's coming from France, for example. Then we're not limited to Australia, or definitely not Melbourne only, definitely not Australia. We go wherever there's a project that needs the capacity. And because most of the Krause around the world are running already very heavy, we're lucky enough that 20% capacity is a lot of freedom for us. It allows for some, I guess, massaging when there is some downtime. We don't have that much on the Arctica, a little bit more on the Krause at the moment, but we still having some teething issues, I guess. But overall, it works very well. I think at the moment our best resolution is 1.6 angstrom. Then we have no problem. Usually the sample is a problem. If you have any questions, we have a website that has some information on the systems and how to access us. It's microscopy.unimel.edu.au. And if you have any questions, just feel free to email me at ehanssen@unimel.edu.au. Thank you very much.
Thanks a lot, Eric. So we'll keep, if you have questions, please pop them up in the Q&A, and we will go through all those questions at the end of at the end of the presentations. So our next speaker is James. So James has a PhD in physics from the University of California, San Diego, and under Mark Ellisman in 2002. James worked thereafter as a principal development engineer, where he designed and built a wide variety of new instrumentation around light, electron, and X-ray microscopes. He was a lead engineer for the development of some of the world's first direct detection device for transmission of electron microscopes. So James later on moved to managing the UCSD CryoEM facility under Ted Baker, and Elizabeth Villa and Andreas Schnizer, and is currently the director of Molecular Horizon Cryogenic Electron Microscopy Facility, that's a big word, and at the University of Wollongong. So that's just south of Sydney, and he serves researchers across Australia, New Zealand, Southeast Asia, and the States. So James, all yours.
Thank you, Isabelle. Can everybody hear me okay? I'm going to go ahead and share my screen. Let me know if you're having any troubles with audio or anything like that. So let's see if this thing's going to go slideshow. There we go. Okay, so I'm James Bouwer, and kind of what we do at the University of Wollongong is we've really been designing a customer-centric approach to doing cryo-EM. So what that means is that we're looking out for things to make the customer's experience as simple as possible as they go through this process. So what we've done, and we recently just completed our CryoEM facility, which is Molecular Horizons. This is the installation of our Arctica just being installed. This is the building. So we've designed some very special microscope rooms that I think are some of the quietest in the world. And all related to that, a lot of infrastructure around how to move data around, how to make it easily accessible to all of our customers. So we're a lot more of an outward facing institution where we bring in customers, we do a lot of the training. Many of the people doing cryo-EM in Australia have been trained at our facility. So that's kind of how we approach things. In terms of equipment, we've got an Arctica, we've got a Krause, we've got a T12, and we've got a few Vitrobots. So the T12, which is this guy you see over here, is used mainly for training, learning how to align microscopes. So we spend a lot of time with our customers right when we get them, training them on basic electron microscope optics and operation. So everybody that comes to us gets trained and is fully capable microscopist by the time they're finished. We also have the Arctica, which is this machine over here. which is getting a K2 upgrade in January. That's used for kind of intermediate resolution. So after you've got your work done on the T12, we move you on to the Arctica. We train you there. You take all your own data, and we help you, and you become self-sufficient. The second instrument we have is the Titan Krause, and that's getting a K3 upgrade coming in January. Full automation. It's got APHIS on it. We're going to have APHIS on the Arctica as well, which means you don't have to move the stage quite as often, which really means you can run a lot more quickly. In terms of getting access, you can go to our website. You can search UOW scheduler, find the scheduler, and request access. We'll put you on the scheduler. You can book your own training time according to how it suits you. It's generally 3 days on the T12, 4 hours each day. And then maybe another 20 hours on the T12 doing negative stain, getting up to speed, practicing your alignments. Then we move you on to the Arctica. We start collecting data and doing the training at the same time. And then from there, we move you on to the Krause with the K2 and the K3 coming soon. So our idea is sort of end to end. So we start you with the sample prep. We train you on the VitraBots. You do all your own sample preparation. You're a lot more dedicated as a researcher to your own projects, and you can stay there all night preparing samples if you want, whereas I'm going to be going home to go take a nap. What we do is we train you on that. T12, we move you through to getting intermediate resolution structures, atomic resolution structures, and then in the background is a lot of infrastructure with local high performance compute and remote compute. We specifically use Massive, which is the big high performance compute infrastructure in Australia, to do most of our heavy lifting, but we also have local high performance compute, which runs a lot of the local processing. And we have the ability now to do micro ED. We're building up all the micro ED infrastructure. Tamir, we've been going back and forth with him on how to do this stuff. So thanks, Tamir, for working with our students. So we get you all the way to the high resolution structure, and we're starting to do modeling and things like that. So we'll train you on every bit of this workflow and get you from end to end, and you'll be being trained as an expert as well. And you can see from all the requests on the job boards, there's a lot of need for experts. This is kind of what our infrastructure looks like. We've got our electron microscope. We've got 2 big data servers sitting on the back end. We just started a collaboration with Panasys. So we've got a big 1.2 petabyte storage server, which stores the data locally. Then we push it down to Massive's resources. We also can push it onto the local university resources. We're starting to work on plugging in Amazon Web Services. So what this means is you never have to move your data. It's always accessible to you. We have multiple copies stored, so it's just an easy way to work with your data. When you spin up a desktop down at Massive, you just spin it up. You can sit at the beach and work on your data while you're collecting data. So I've got a couple really good engineers working on that, Josh Silva and Jason Andretti, who are these guys when you get them in the server room and on the IT solving problems. As Eric said, a lot of on-the-fly stuff going on. So we know immediately if your samples are working, if they're going to work, we can stop immediately if it's not going to work. And by the time we're finished collecting your data, we have a structure for you, and you can just upload it automatically. We provide access to all of our customers from external organizations into our infrastructure to work on their data, upload their structures and everything like that. We do a lot of training and workshops. So this is a workshop we did with Thermo Fisher, and we do little incentives to make a really nice sample for the winners. And of course, this is a big thing in Australia. And one thing I really love about Australia is we all work together on various projects, and this is one of them. This is the ARC training program led by Patrick Sexton, and you can see we've got a lot of industry collaborators and people interested in having the future CryoEM scientists being produced at our facility. And then there's another big collaboration with Monash, which is building the high performance compute infrastructure backbone so that everybody can work on their data. And here you can see some of the people we're working with locally and in New Zealand, and kind of our plans to take over the world. So that's it. Thank you very much. And happy to take questions at the end.
Thanks a lot, James. So our next speaker is Harry from Monash University. So Harry is a senior microscopist at the Ramakirti Center for Cryo-Electron Microscopy. He's in charge of all the high resolution imaging as well as single particle analysis and tomography workflows. So prior to joining Monash, Harry delve into the world of CryoEM while working with Dr. Alok Mitra at the University of Auckland, New Zealand. His research are mainly in structural biology, high-resolution transmission electron microscopy techniques, single particle analysis, and cryo-ET. So all to you, Harry.
Awesome. So hi there. Hello, everyone. Good morning or good evening in States. And okay. So my name is Hari Venugopal. I am a microscopist at the Monash University Center for Cryo-Electron Microscopy. We are part of Microscopy Australia Victoria node, and we are housed in Monash. So what do? We basically cater to all sorts of electron microscopy needs in biology, all the way from classical EM techniques to single particle analysis, and of late we are delving into cryo-chem and in situ structure biology. So what do we have? So we have quite a few electron microscopes. We were one of the first in Australasia to house a Titan Krause, which happened in 2015. So it's a generation 1 Titan Krause. It was equipped with K2 bioquantum energy filter from Gatan, and it has Falcon 3 also, and Theta D, which was then moved to a Talos Arctica, because we had better stage control on the Arctica. So we have a Talos Arctica, which has a Falcon 3 detector, and the K2 is now moved from the Titan Krause to Arctica, and because we have got a K3 now installed on the Krause. And then we have screening microscopes like Techni 12, Techni 120 systems, and Joel system. And we have CryoFIPSEM, and we have a variety of other equipments to support sample preparation, basically with robots, single-sided blotting, double-sided blotting, and a cryoclean system, and also the high-pressure freezing systems. So since most people are interested in the single particle analysis side of things, so our workflow is similar to most people in the world. There's no shortcuts to this. So basically you come to us with a project, we set up project discussions, and then we quickly move you to training sessions. You start off with negative staining, get used to lower kV microscopes. And then once you have got a handle over your sample and microscopy, you will understand more, you will appreciate more of your sample, and you get better decision making, and then we help you in this process. And also then you then quickly move to seeing if your sample is good in cryo. And then once everything is established at a lower kV system, we can then move to Talos Arctica, which I use it to say screen for structure, basically. So here you can basically understand more about your ice quality, how your sample is behaving. Sometimes your sample does not like thin ice, it likes thicker ice, and all those kind of things. If you need to do certain additives and screen through a variety of conditions, Arctica is a better system to do that. And also for screening for smaller molecules. And at the end of it, screening for structure, because we can quickly take 100 images, 200 images and process through it and see if you get secondary structure level details. And then if things are looking good, no use wasting time, you can move to the higher end Titan Krause. And for most projects, to be honest, Talos Arctica is a fantastic system. Okay, so typically most people have this question of what can be actually achieved with biological samples on say a Titan Krause or an Arctica. So in this case, let's say Titan Krause, we have a generation 1 Titan Krause with an S spec, so it's not as fancy as most of the newer systems are. But what can be achieved? Well, basically, these systems are quite well made. The physics and the engineering behind it make sure that you get high resolution data out of them. So for instance, if you put in a material science sample like oriented gold over here, you zoom in all the way on a well-aligned microscope, you can see gold atoms. So you are not limited by the microscope for your resolution. But there are challenges with biological samples because they are weak phase objects and so on and so forth. And you have to average many thousands of particles from thousands of images to get to this kind of resolution. And we are not close to this kind of resolution, seeing atoms. So what has happened in the field, basically in 2019, with the advent of Coldfec on a cryo system, with the 300 kV system, I think Namba Lab solved apoferritin, which is kind of a oriented gold sample for like TEM. We get good resolution out. So they crossed 1.5 Armstrong barrier. They basically were at 1.5 Armstrong with that system with 120,000 particles. And then subsequently, we heard how double corrected system by Holger Stark, and in MPI, they got it to 1.25 Armstrong. And I'm talking about data collected with, so this was the CryoEM data was collected on a K2, and the Holger Stark's data was collected on a Falcon 3. And then subsequently, we saw that with Selectris, with a better energy filtering device and a narrower slit width, we saw how the thermo systems could deliver 1.2 Armstrong without double corrected systems. So taking some cues from there, we thought, okay, we will see what we can do with our generation 1 Titan with an S spec, nothing fancy going on, and with the good sample like apoferritin. So we collected 1,800 movies, and the lesson we learned was that the slit width really matters. So we wanted to see how much that can affect us. So we could get to 2 Armstrong and slightly sub 2 Armstrong before, but then when we perfected this slightly tighter energy slit width, we could get to a very good structure with 1.56 Armstrong on an S spec with a K2 and with a tiny amount of particles, with this only 60,000 or something. So these lessons are basically lessons on workflow and how to take some certain decisions on certain kind of samples. And then now we have a K3 on our system. The K2 has moved to the Arctica, and then the K3 is also giving amazing results. So this is a non-apoferritin. So and this is from a fantastic collaboration from Reese Printer at the microbiology department in Monash University. And we got this floppy C4 symmetric, well, I will not talk much about the biology, C4 symmetric object where we could do some symmetry expansion and just look at one of the component, and it has a C2 symmetry on it. We could get it to 1.57 Armstrong, and you can see the map quality. So this we can achieve similar results with our system now, so which gives us quite a lot of confidence, and the learnings that we make is actually making across the projects we can see a bump in resolution happen. So yeah, so basically these are the people involved. So our I would like to thank Georg Graham, our head of the facility, who gave me the opportunity to speak in this, and the amazing staff we have. Each one of us have our own expertise. John Clark is a microtomy expert. Jill Dane is an immuno-EM expert. Simon Crawford is a jack of all trades. He knows everything, TEM, SEM, and he's the person who takes care of bulk of the training. Rachel just joined our lab. She's from EMBL. She's our CLEM expert. Gary Minias is our FIPSEM expert. And if you guys have not subscribed to the Krause meeting, please subscribe. Gigi is going to talk in it, and you will see some really fantastic results. And then also the funding bodies and Microscopy Australia for the support. That's basically it from me.
Thank you so much, Harry. So we're going to move to our last speaker is Melanie. So Melanie is a parasitologist by training, and with a research focus on molecular, biochemical, and cell biological investigation of the host-parasite interaction of the malaria parasite. She completed her studies in Germany, Heidelberg, and then relocated to La Trobe Uni on a postdoctoral research fellowship and later moved to WEHI as a senior research fellow, where she study different aspects of malaria parasite-induced trafficking pathways. So during that time, she really gained extensive experience in the application of wide-range light and atomic force and electron microscopy technique. And in February 2012, Melanie joined the Center for Advanced Microscopy at it's called CAM at the ANU, and has been appointed as a director of the facility and the Microscopy Australia node in 2014. So her interest as well is in transmission and scanning electron microscopy, TEM and SEM, as well as a combination of all the microscopy techniques, CLAIM, and with advanced CryoEM and so on. So Melanie is establishing a facility. So all yours, Melanie.
Thanks very much, Isabelle, for that very kind introduction. Yeah, and as Isabelle said, we at the Centre for Advanced Microscopy are only at the beginning of our advanced cryo-EM capabilities journey. So it will be very different to the very established capabilities that you've just seen in the other nodes. On this picture here, you see that CAM is located in the John Curtin School of Medical Research building at the ANU, which stands on the land of the Ngunnawal people, the traditional custodians of the land, and I'd like to pay my respect to their elders past, present and emerging. And on this picture as well, you can see that CAM is conveniently located across the road from the National Computational infrastructure here, which gives us fabulous opportunities for fast processing and data storage and of course sharing capabilities. And we're also located next to another imaging lab, which is the computer tomography lab right next to us here. And together with the CT lab, we are the advanced imaging precinct at the ANU. And we are one of the 9 core facilities within the Microscopy Australia network of NPRIS supported facilities across Australia, which are all open access. And due to being part of that network, we report metrics back to NPRIS about the AIP, the Advanced Imaging Precinct, every year. And here's just a snapshot of some of the data from last year, from 2020, to give you an idea of the size of the facilities at the ANU. You can see that we had about 200 active users in 2020, and they were clocking about 16,000 instrument hours in our facilities. We have had about 90 users that were trained one-on-one, and we have a similar model to the previously mentioned models, where we mainly train our users to use our instruments, but we also do collaborative work depending on the research that is done, and also we have a fee-for-service structure as well. And so all of these research projects last year contributed to about 100 publications. The pie chart here shows you which disciplines we support, and you can see that the cryo capabilities I will be mentioning is supporting just slightly over 1/3 of the users of our facility. CAM currently has 8 staff members, with some life sciences here in yellow and some material science specialists. But since we're a very small team, all of the listed members are somehow involved in the cryo workflows that I will present in one way or another. And we're very pleased that our cryo-EM platform scientist, Jobijan Chako, he could join us from Singapore just 2 weeks ago, so he's just freshly joined the facility. And we also have a dedicated data analytics engineer, Chung-Han Tsai, who works with all the data processing and storage pipeline for CAM. And then you can see down here, we've also got 1 vacancy, and we're just in the process at the moment of recruiting a person who can hopefully support our collaborative workflow. We have a well-established cryo workflow at CAM for over the last many years, actually, which includes cryo-SEM imaging and elemental analysis of cryoplane samples. And we do also routinely cryo-TEM analysis of liposomes and small microvesicles via cryo-TEM. But of course, we are now looking at our new facility, and this slide shows the new cryo instrumentation at CAM, where installation started with the Zeiss crossbeam with a Leica cryo stage end of last year, and continued with the installation of our cryo-TEM duo, depicted here, the Joel F200 with a cryo ELSA holder, and the cryo ARM 200, also from Joel, for automated analysis of SPI and hopefully tomography samples. And that continued all through the year. And the last engineer has just left last Friday. We have direct detectors on both of these instruments, both from DE. On the F200, we have a DE16, and on the cryo arm, we have a DE64. And additionally, on the F200, we have a Ryo 16 4x4 camera for more routine imaging. And here on this slide, I've just compiled the new cryo workflow that we're planning to have established soon. We're currently in the process of establishing this, where we can go from small samples via plunge freezing straight to of one of our cryo-TEMs, of course. And if we have larger samples like cells or tissues, we can go via plunge freezing or high pressure freezing to all sorts of different intermediary steps via on-grid lamella preparation or fib milling if we wanted to do volume imaging, or we will also try to embark on lamella lift-out methods to go into all the wonderful techniques that you heard over the last few talks that were presented in this seminar series with, of course, cryo-ET, micro-ED, and also cryo-volume imaging. And but since you've heard about all of these methods in the previous talks, I thought I'll just concentrate on what we're establishing at the moment in terms of the cryo-CLEM, where we brought a cryo-LM stage into the equation to actually go through this workflow. And this is just showing you how we're planning to go about this. And here we would have fluorescently tagged cells viewed on our cryo light microscopy stage to acquire 3D stacks of areas of interest. We then transfer the samples to our cryo sample prep station to transfer under vacuum into the FibSem that we have, the crossbeam, the Zeiss crossbeam. We would then import them the Zen Connect project that we generate on the FibSem into there and target areas of interest by navigating via fiducials of the sample. We can subsequently hopefully cut a cryolamella of the region of interest on the FibSem and correlate the two images, hopefully without contamination. We then transfer the lamella into our cryoarm TEM for the electron tomography, and then to reconstruction of the tilt series and subsequent segmentation of the features of interest. And in this last slide, I've just depicted the instruments that we have for this workflow. And those are a plunge freezer and a high pressure freezer, both from Leica. We then would go onto our light microscope, which is an LSM 800 AIRI scan from Zeiss, and has a cryo-Lincoln stage attached to it. That then transfers onto the VCM, the Zeiss VCM sample preparation stage, and we have also a coater and the transfer shuttle from Leica to go onto our crossbeam, which has a Leica cryo stage. The cryo-electron tomography would then be done on the Joel cryo arm, and the processing would happen via our, of course, the GPU server that we have established. And so our analytics engineer, Chung-Han Tsai, has designed a pipeline for us that's actually partly set up as we speak. which is the hardware for the real-time processing and quality assessment at CAM via our 8 GPU server, which is depicted down here. And additionally to that, everything is also set up for batch processing through NCI, which is across the road from us. And if you have further questions with respect to the processing and the storage, Chung-Han Tsai is actually part of the audience, and I'm sure he's happy to answer any questions you might have. And with that, I'd like to thank the organizers for giving me the chance to talk about the CAM facilities. And please, if you have any questions, contact us via those emails that are depicted here. But also, I'm very much looking forward to the discussion so we can talk further about what we're planning and what you might be able to achieve at CAM. Thank you very much.
Thank you so much, Melanie, and thank you to all the panelists. In the interest of time, we're going to move to questions. So there's a couple of questions and similar questions. One from Richard Birkenschott, Wihai, and Emily Furlong. Do any of those facilities have options for remote access to microscopes? Not everyone can go on site to any of those microscopes. So is there something that you've been looking at? I can start with James and then move on to Eric or whoever wants to take on this question. So what is the future for remote access?
This is James here. In terms of remote access, when we first installed our Krause, it was up at the nuclear facility, ANSTO, and we ran the thing exclusively remotely, which was interesting. We've recently just started putting into place testing remote access for our customers with Alistair Stewart. There's a lot of firewalls and things you have to jump through, so it's a big thing with the universities, but yes, remote access is set up and we're just testing it right now on our new installation. So definitely possible. You kind of have to send out maybe a suitcase with the hand panels and all that sort of thing. So it's a little bit of a collaboration going on with Thermo Fisher to build those sorts of systems.
Yeah, thanks, Eric. Do you want to?
Yeah, I guess there's a couple of, we're pretty much on the same boat than James with the firewalls and things and the bandwidth from the user is a big issue as well. I tried on my old network at home and it was horrible. Now with NBN, it's much better, but there's still some issue with the hand panels. If you don't have hand panels, you can't really do alignments. As a rule, we don't let users remotely control the microscopes completely. What we have set up that works is we have a specific Zoom meeting address for observing one of us setting up the microscope for remote people. Then you can see the screen, select the squares that you want and basically set the session up. You don't have to align the microscope or anything. But at the moment, we're not going to leave anybody remotely access the microscope.
Harry, is
yeah, I think that I'm pretty much in page with what Eric was saying. Yeah, so yeah, we have done remote sessions wherein the users interact with us via Zoom, and we can also share the screens of what we are doing, and then they can tell us what to do with their samples. So this is on the Titan, but on the Arctica, increasingly we are training more and more users, and they are becoming quite self-sufficient and expert at what they are doing. So in future, yes, this remote availability will be made available. There's no problem. The only problem is bandwidth for us, but we all do it remotely anyways. So this capability can be easily transferred to the users.
Okay, I'm sure everyone has in mind. I'm just throwing a question there in terms of the cost of CryoEM and the cost of the experiment, and not necessarily knowing how long this experiment will take. So, is there do you have for your facility a pricing that you make available on your website, or how do you go with this? And because I don't think there is an aligned price across the whole facility, and that might be some restriction due to the institution. But so if you could indicate to people where to find the pricing, that would be great.
I've put this on the chat. Our pricing is on the website, and then we had an interesting exercise with James a little while ago, and Matt Dozer from Monash, where we have slightly different pricing. If you look at the sheer pricing, but you put a project together, and it turns out to be very similar, really. And when I say similar, I think we did the math for students, and we were all within $500 of the $20,000. It's pretty much the same.
Right. So ours is also on our website. Just Google UOW CryoEM, and you'll find the rates there. We do collaborative rates as well. And ours is sort of just a one-time fee to access the microscopes, and then we provide you free access to the rest of the infrastructure at the facility. So it's a pretty simple process once you're signed up, and you pay for your microscope time.
Thank you.
And for us, we also have all our pricing on the website, not for the CryoEM yet, because we haven't used that yet in that capacity, but all the other pricing is on our website. And then for collaborative work, I usually ask people to contact us, and then we can work out a fee.
So while we at on pricing, so where do you think where are the financial plans for maintaining the service contract of all of this high-end EM at each of the location? And is there something to do more nationally, basically?
That is a great question. I think we're all in the same boat on that. We usually, we're supported by the university very strongly. I mean, we pay the service contract. We've been doing this for 15 years now. To the benefit of the official and us, because without it, it's a problem. But at the moment, the current plan is on our side. The platforms have as an ongoing support from the Chancellery, and our service contract is paid, at least on the instrument on purchase, and we pay 5 years on purchase. And hopefully we change instruments every 5 years, which is not quite right. That doesn't quite happen that way. The Arctica is just coming on service contract next year. After 5 years of faithful running here, but that's always a difficult one anyway. There's no, there is no plan official plan after 5 years. We know we're going to be supported, but it's, the plug can be pulled at any time. Really.
Yeah, so there may be some length at some point to regroup and start to think about a more, sustainable way to maintain those high end, and what at the national level, who can we can be lobbied to try to get some support, probably through increase to build a national framework to allow the sustainability of those high-end capability. So there was another question in relation to that question for Horn and from Matthias Fellner is, what is the percentage of CryoEM time bought by industry with or without collaboration, and what kind of sample, if you have some industries mostly looking at? Do they have their own CryoEM capabilities? That's an avenue that need to be more partnership with industry. Do you have any contact with specific industry? James, Eric,
so we have a contract already in place with Thermo Fisher, which would kind of involve maybe a little bit of doing some training and bringing their customers in. Right now, besides that, we don't really have much industry collaboration. I did at one point have something going on with Pfizer in San Diego, which was drug research stuff. But the CryoEM training facility for membrane proteins is really one of the big drivers from industry to start to provide them with people that know the field and can work in drug design and things like that.
Okay.
For us, we have a strong partner in industry, which is CSL, and they have basically purchased part of the microscopes when we purchased all the microscopes. They were partners in the grant, or they were partners in the purchase. of ultra-wide microscopes. And in terms of access in percentage, it's negligible compared to the overall, but as a partnership, it's very important.
So we have basically industry collaboration through users mostly, and there's a fair bit of them, especially some from VHI, Mike Lawrence and Patrick Saxon at MIPS. So basically that's how we have dealt with industry, but we haven't dealt with industry where there have been few cases, but not something very meaningful yet. Yeah, but yeah, looking forward to. Well, we have the capability and the instrument time. I think it's not a limiting factor right now.
Yeah. We're going to move some more practical questions. So to Melanie, how much time does it take to prepare a CryoEM lamella?
That's a good question. I think the lamella preparation itself actually takes about half an hour. But of course, it depends on your sample. So we are only at the start of doing all of this, and you know, getting the right sample is really the key, as you've heard in previous talks as well. Preparing the sample well, and then I think Gigi is in the audience, so he would be a person who can tell you he does routine lamella prep every day, basically, and for him it's probably a matter of really, you know, half an hour for each lamella, and he cuts, I think, 6 lamella on each grid, so that would be roughly the time frame, I would say, but you need the experience for that.
Yeah. Well, I've got you another question. Is it possible to do cryo lift out with your setup?
Yes, it is in theory. We haven't done it yet, but we've got cryo grippers on our setup from Kleindi.
So there's many probably crystallographers in the audience, and we're all itching to know that if all the facilities will have the capability or experience to perform micro-ED experiments.
I can sort of start to field that if. So we've just started building the pipelines and setting up on the various local workstations and GPUs, the computation side of things. We have a CETA camera that a CETA camera that we're using right now to do micro-ED, but we're planning to take that to the K2, which makes me a little nervous, but we'll see how that goes. So all of that stuff is sort of being built up right now. So in the next month or so, we should be quite capable to do those kinds of experiments.
Eric, I know you're cooking something as well in that space.
It's ready to go. We just need the projects.
Nice.
I think we had a couple of projects in the last 3 weeks that came in, and mainly the crystals were not diffracting very well. Or not many crystals were diffracting either because too big. After 10 years talk, I've increased the size of the crystals because I was going way too small. But things that you couldn't see at all. But now it's basically running very well.
Harry? Yeah.
Yeah, well, we don't have the CETA-D as per se, but we have the precursor to the CETA-D. Well, as it happens, this person over here is Chris Lupton, and he's the expert. So yeah, if you have any micro-ED specific questions, that's where you email to.
Great timing.
Yeah, great timing.
Thanks. James, the question for you is a massive HPC cluster only located at Monash? No, I think, is it the upload to a node more local to Wollongong? I think the massive is
so
everywhere.
I think that's kind of an infrastructure question more broadly. So we have a set of storage servers that sit local in our storage room, and we can write to those. We also have a Panasys storage server, 1.2 petabytes. So the data is automatically moved from our K2 systems and also our Arctica Falcon 3 directly onto the Panasys system, and then we duplicate from Panasys, we duplicate that data down to Massive. And so You can work locally on our V100 local cluster on the local data, or you can work remotely on the massive cluster on your data, which is at massive. So it's kind of, it's sort of modular. We can plug things in and out to make things work and easy for our customers.
Okay, and on the XU, I think you replied to that. Do you have a CETA or CETA-D for micro-AD? James?
Yeah, like I said, we're running a CETA camera just to set up and get everything working. We're planning on using the K2. We've also got a K3. So we're sort of still a bit in the experimental phase. If all of this works, a CETA-D might be the next option. But I have people telling me that these direct detectors, it's not as dangerous as I think it is to do diffraction on the direct detectors.
I've got a question for all of you before we close this meeting. So now you have, for most of you, you have established workflow. What still remains the bottleneck in your view in terms of going from sample preparation to structure? What is the main thing that stop if you want the workflow quite quickly?
People.
People?
We don't have enough. We don't have enough users trained properly from A to Z, basically. I think more than anything else, the rest seems to be running smoothly, whether it's data transfer, microscope. I mean, there's always some teething issues on microscope anyway, but mainly it's the project and the availability of student postdocs and staff to really go into the nitty-gritty and really drill down the sample prep on their side. Sample prep is where the bottleneck is. The microscopes, when they're running.
Okay, James?
Bottlenecks right now, I'd say primarily getting customers into the facility to get trained. So it's for our facility, it's Simon Brown, who's my right-hand man, and myself. We're the only two staff. So for us, our staff becomes the customers that have been trained. So it's right now it's putting a lot more work on our plates to get that done. So I'd say that's the primary challenge at the moment. I think everything else is pretty smooth flowing and running very smoothly. So I'd say that's it.
Yeah, I think instrument time wise, it's not a problem. I would say it's a mountain of data that's being generated. That the management of it will become a problem at some point of time. If not, it's already a problem. And actually user training, basically. Because every project is basically the limitation. So some people will have extremely fine projects, like your protein is well behaved, no problem. You put it on a grid, the next day you get a structure. And the other people, they basically struggle for years on and still have problems with their water interface and whatnot. So I think, yeah, as a community, I think the biggest place to invest is the sample preparation part of it, like chameleon and all those kinds of things. It will be interesting where that goes. But in terms of processing, microscopy and all, I think most of the things are sorted.
Okay.
Yeah, it's the data management which is a problem. Yeah, and staff. Yeah.
Yeah. Well, hopefully that will be solved soon. I mean, this was we all part of the a few of us are part of the ASC Center training for CryoEM of membrane protein, but that should hopefully be expanded to not just membrane protein, but to the whole CryoEM community. So I think we need to stop here. Kurt, I hand you back to you. Thank you again, everyone, for all the showcasing the current Australian CryoEM infrastructure. And Kurt, do you want to add a final word?
Good thing. Thanks so much, Isabelle. Incredible job. Thanks very much to all the participants, and thanks, Isabelle, for moderating the session. I think it was really, really informative, and hopefully that a number of the users or the people in the audience will be able to send data and participate in data collection at a number of these facilities. Thanks everybody for joining us for this series. We're looking forward to perhaps running a series like this again next year. So we'll be in touch about that.